this video, I'll show you how to build a complete machine learning project step by step. We will predict whether a person is likely to seek mental health treatment, whether using a survey data, and I will explain every line clearly, okay? First of all, we can name the file. So, as I already posted the shots of this file, so you may find the code in GitHub, but I'm also giving it again. We name it as mental health treatment. Okay. So let's start coding. First of all, we install and import all the required libraries. Here we need pip install. We are installing Pandas NumPy. Maybe you already had the requirement, but to the fresh viewers, doing it again. Scikit-learn, Matplotlib Seaborn. And we need some of the imports. Import pandas as PD. Import numpy as np. Import matplotlib.pyplot as pld. And also Seaborn. Okay. So here we imported pandas and numpy, which is used for handling the data. Scikit is for machine learning, as we all know, and Matplotlib and Seaborn help us visualize the results. Okay, so we understand the purpose of all these imports. I will say it again. Pandas and NumPy will help us to handle the data, and Scikit is for machine learning that we use here, and also the Matplotlib and the Seaborn help us to visualize the results. Okay. First of all, we need to upload the file. I'm uploading from my browser. So it's connecting. So I need to upload. So I will upload and show you. So now look here, we can see whether it's uploading or not. When the loading is completed, then only we can understand it is uploaded. If it's still circling, it won't be uploaded yet. Okay. So currently it is uploaded. So now we need to unzip the file. For that, we are going to unzip it. First, we need to know the file we uploaded. So the ls can help us to know which file we are uploading now, and then I'm listing the files to check what files are available in Colab environment, and then we will unzip it using apostrophe unzip archive 6. Okay, we can run it. So it is unzipped. It is called mental health dataset that I have taken from the Kaggle, and the dataset is inside a zip file. So I unzipped it using the unzip command. Now we need to load the data. For that, just load the data. So for that, we are df equal to pd data frame dfo read csv. The file is in csv format. So, and use /content/ the name of the file. What is here? This is the name of the file, which can just copy and paste it here. Mm. Do you know why this happened? Because we didn't run this file. Actually, I forgot to run it. So I already downloaded all these things, requirements. So we just need to run it again. So there will be gone. So now I uploaded, means I load the dataset using Pandas read CSV. This dataset contains survey responses related to mental health, and head function shows. Now we will do that after it complete running. We can say df.head. So this head function shows the first 5 rows so we can understand the structure. The file will be an unzipped zone. Because we run it again, we can run this now.
Anhinyo dohi dumo. Wedding helping them have did.
So we can run it again. We find the head of the dataset. That's 5 of them will be shown. And we need to understand the data. First of all, we need to understand the shape of it. So df.shape, we get it's in 17 columns and 200, about 2 lakh rows, I guess. And we can understand how many columns are there. So these are the names of the columns. Through this code, we can understand or fetch the names of the column. And then we need the information. So we use brackets here. Just remember the codes, okay? Not everything, but some has functions and some are not. So understand that. So we get the basic information of all these data. So here I am checking the number of rows, columns, viewing column names, and understanding the data types and the missing values. This step is very important before applying machine learning because we need to understand it. Otherwise, we might have some error. Okay, then we need to drop the irrelevant column. So here we don't need timestamp. So I'm going to drop it. So we are using df. Df dot drop is the keyword and using columns and give the name of the column. Here it's timestamp. Just make sure your spellings and the cases are right. Okay. Now it is over. We dropped the timestamp column. So the timestamp column does not help in prediction. So I removed it to avoid noises in the model. And now we are going to handle the missing data, okay? So for that, we need df equal to df dot drop now. And to keep the project simple and clean, I remove all the rows that contain missing values using this code. Okay, we will run it. We'll just run it cleanly. And we need to encode the categorical data. Okay. Okay, we are encoding the categorical data. So for that, we are calling from Scikit-learn dot preprocessing. We need to import, as we know, the label encoder. So, and then we use label encoder for, need to understand, for call in diff dot columns. We know the names of the columns now. df dot call equal to le dot fit transform, and then df call. Okay. So we need to connect it ft to df. Okay. And then we'll run it. There's a syntax error. We don't need a full stop here. So run it again. Then machine learning models cannot work with test values directly. Since all the columns are categorical, I use label encoding to convert the test into numerical values, as we do here. Okay, now it's converted to numerical values. For that, we use the label encoder. I hope this step is clear because it's an important step. And then we split the features of that and target. Okay, for that, x equal to df dot drop treatment, and in the axis equal to 1, and y equal to df dot df treatment. Here the x contains all the input features and y is the target variable. So whether the person seek treatment or not. Okay, hope there is no error. Now we are going to train, test and split it. So we need to train, test and split it. For that, from Scikit-learn dot model selection, we need to import train, test and split. Okay, then we need to train, xtrain, then ytrain, xtrain, then xtest, then ytrain, then ytest, and here actually we do, I split the dataset into training and testing sets. 18% is used for training and 20% for testing, which help us evaluate the model fairly. Okay. Now we need to train the random forest model. So that is a model we use here for now. So we can write the step random forest model train Okay, for that, from sklearn dot ensemble import random classifier and model equal to, as we said, random forest model classifier and estimators equal to 200 and so I use the random forest classifier because it is powerful, accurate, and provides future importance. The model is trained using training data as we do here, okay? We understand how it works. We use the random forest classifier because it is more powerful than many other models and it is accurate. Because of that, we used it here. Now we are going to do the model evaluation part. Before continuing our next parts, we need to run all this. It will take a little bit time, so let's wait and talk about this. This is our model evaluation. Now I evaluate the model using accuracy and classification report. As we see here, we import the scikit-learn.metrics. From there, we import accuracy score, classification report, and the confusion metrics. And we wrote the Y prediction, Y predict. So through this, this will tell us how well the model predict the mental health treatment. Okay, because of that, we use the Y predict here, and we just print both the accuracy and the classification report. Okay, nothing more is happened there. Okay, it may take a little bit time, so let's continue our coding. Okay. Now we are moving to the confusion metrics. The confusion metrics usually shows the correct and incorrect predictions. Okay. So before that, the random forest model is run correctly. So executed correctly. So we can see the n estimator, the random forest state, all that here. And it also run the accuracy and classification report. From the we understand the accuracy, macro average, weighted average, all this precision, recall, F1 score, support. I will take a brief class on this someday, maybe soon. Okay, today let's discuss or talk about this project. So this is our confusion matrix. The confusion matrix visually shows correct and incorrect predictions. Okay, this is how it show actual predicted. Okay, we can see both of that. This helps us to understand the performance more clearly. Okay, from the score here we can understand how it really works. When it's 25,360, it will be in the top level, and 3,000 is almost the lowest. Okay, from that, we can understand how confusion metrics work here. Now we need to know the feature importance. This feature importance will tell us which part of factor is influencing the treatment. So now we look the feature importance, and this had explainability to the machine learning model. So we can run it. This shows what all this shows, the important features and which are the factors influencing the treatment decision and all. From this we can understand all that. Here the timestamp is the main factor, then the family history, country, care options, and the least one is mood swings. Okay. I would like to talk about this, but it's like the pandas. We are using the panda series to write this code, and to know the importance or show the 10 main hertz of importance, we use the 10 here. Also, we need the sample prediction. So our code is almost done. Finally, I test a model with a sample input to see the predicted output. Okay. So here we get prediction. 1 needs treatment and 0 needs no. So 1 is treatment, and if it's 0, we don't need any treatment. Now it's predicted as 1 because it needs treatment. From the sample, we can understand that the person need treatment. That means it showed 1. This completes the end-to-end machine learning project. We handled data processing, trained a model, evaluated it, and explained the results. So GitHub link will be in the description. Thanks for watching, and I'm really sorry for this hurry-burry.